Hello and Namaste. In continuation of the rectification length for plane curves, we are moving ahead with the polar form. Part 3. Find the perimeter of the lemniscate r square is equals to a square cos of 2 theta. We are differentiating the equation of the curve or lemniscate with respect to theta. We'll be getting 2r dr upon d theta is equals to a square into minus of sine 2 theta into 2. Moving ahead with this, taking out just the value of dr upon d theta is equals to minus of a square upon r sine of 2 theta. Now this is what is the lemniscates we have to consider here for this particular curve. Okay, now for the arc OBA, let me draw, let me just trace that curve or this particular curve, which is nothing but this part, which is OBA, which is moving from 0 to pi by 4. So this particular curve is moving from 0 to pi by 4, but we need to find out the perimeter of the entire lemniscate. So entire this infinity curve, or you can say the 8 curve. So we have got 1, 2, 3, 4 part, and therefore the perimeter of the entire curve or the entire lemniscate is nothing but 4 times the length of the arc OBA. And therefore it's nothing but 4 times integration from 0 to pi by 4 square root of r square plus dr upon d theta the square d theta, which is nothing but just putting the values of r square and dr upon d theta over here, squaring them, we'll be getting this type of the equation. Now look at this r square. Now r square is nothing but a square cos of 2 theta. This is what we have replaced here with. Now after replacing over here in this with the a square cos of 2 theta, after the cross multiplication, after adding the few terms, so it's a very simple thing we have to do it here. We'll be getting the next step. Please find out few steps in between so that you will be getting engaged yourself in this particular example. So it's nothing but square root of a to the power 4 upon a square cos of 2 theta d theta. Now a to the power 4 upon a square will gives us a square. A is out, so we'll be getting here 4 times a, which is 0 to pi by 4. 1 upon square root of cos of 2 theta d theta. Making a move to the next page, if you'll observe here or a slide, this is what we have left it last time. And because we need to have it such a 2 theta and the limit is pi by 4, we can easily make a move to the beta function using the substitution. 2 theta is equals to t, 2 times d theta dt is equals to this. Please follow this particular playlist of the channel for the beta function. You will understand this particular question very well with the help of beta functions and the properties of them. So therefore, when theta is 0, t will move to 0. When theta is pi by 4, t will move to pi by 2 because of this substitution. And therefore, perimeter of the curve, which is 4a by 2, because of this over here, 0 to pi by 2 dt upon square root of cos of t, which can be written as 2a into 2a 0 to pi by 2 sine to the power 0 t into cos t to the power minus 1 by 2 dt. That means b is equals to, or this is the formula what I'm talking about, the beta function. Beta of p plus 1 upon 2 comma q plus 1 upon 2 is equals to 2 times integration from 0 to pi by 2 sine to the power p x cos to the power qx dx. That means here in the present case, we have got the value of p is equals to 0. We have got the value of q is equals to minus 1 by 2. Taking these values, putting it over here, we'll be getting the value of beta, or this particular value, as a times beta of 1 by 2 into 1 by 4, which is nothing but using the formula, or you can say the beta of m comma n is equals to gamma of m gamma of n upon gamma of m plus n. This is what we have done it over here. Now this will gives us, again there will be one more property of the beta function, that is gamma of n into gamma of 1 minus n is equals to pi upon sine of n pi. We will be applying this type of thing over here because we do not have gamma of 3 by 4 is present, but we need to have it here gamma of 1 by 4. So multiplying and dividing by gamma of 1 by 4 over here, so we'll be having like this 1 by 4. So we'll be getting this type of equation. Check the denominator. Denominator is gamma of 1 by 4 into gamma of 1 minus 1 by 4, which will be giving us, using this formula, gamma of 1 by 4 into gamma of 1 minus 1 by 4 is equals to pi upon sine of pi by 4, because the value of n is equals to pi by 4, we'll be getting this value. So this is what we are getting it. But sine of pi by 4 is nothing but square root 1 upon square root of 2, which will be getting us this type of way. And if you'll observe, if you'll just go on solving it and go on just doing it, we will be reaching towards this answer, which is a upon square root of 2 pi gamma of 1 by 4 the whole square, which is the perimeter, or you can say the length of the entire lemniscate or 8 curve of this particular type of equation. This is all about the rectification of the polar form, the curves which are there in the polar form. Stay connected, stay tuned for the upcoming sessions. Thank you so much. Happy learning.